Hey guys, Mr. McKinney here, just going through tangent, normal, and secant lines. Alright, so when we talk about tangent lines, we're talking about the instantaneous rate of change. When we talk about secant lines, we're talking about the average rate of change. Normal lines we kind of just threw in here because they might reference normal. It basically just means that it's perpendicular to the tangent line. Alright. First problem, find the slope of the tangent to the curve at the given point. So f of x equals negative 5 over x, and I want to know what the slope of the tangent is at x equals negative 12. Anytime you want to know what the slope of the tangent is, that in your brain should say we're dealing with the derivative. So, I need to find the derivative of this equation. I should rewrite it in the power rule, or so that I can use the power rule. So negative 5x to the negative first power. So now I can use the derivative, the power rule to find the derivative. So f prime of x, negative 1 times negative 5 turns into positive 5, and then I drop the exponent down to negative 2. So the equation for the derivative is 5 over x squared. Now, if I want to know the slope of the tangent at this point, I need to plug in that point. So f prime of negative 12 would be 5 divided by negative 12 squared. So f prime of negative 12 would be 5 over 144. F prime refers to the slope of the tangent. So the slope of this curve when x equals negative 12 is positive 5 over 144. And if we think about what the graph would have looked like, it would have been a rational function flipped. Instead of being in these two quadrants, it would have been flipped. It would have been in these two quadrants. If we think about out at negative 12, we would have a slightly positive slope, but much less than 1. So my answer of 5 over 144 makes sense. All right, let's try another one. Find the slope of this equation, find the slope of the tangent for this equation when x equals negative 2. Now, this one looks a little bit different because we have x plus 5 on the bottom. What some kids would want to do is make it negative 2 over x plus negative 2 over 5, but that would be wrong. That's illegal math. You're not allowed to do that. So what you're going to need to do is rewrite this equation as negative 2 times x plus 5 to the negative first power. And now we're going to use the power rule. So negative 1 times negative 2 turns into a positive 2, x plus 5. And now remember to drop the exponent. So negative 1 drops down to negative 2. And I want to know the slope of the tangent at that particular x value. So I really want to know what f prime of negative 2 is. So 2 times 3 to the negative 2 power. Because when I plug in negative 2 plus 5, I'm going to get positive 3. And then let's get rid of the negative exponent. So 2 over 3 squared, which is 2/9. So the slope of this equation when x is equal to negative 2 is 2/9. And again, we can do a quick check. It'd be a rational function shifted 5 units to the left. And then it would have been reflected. So instead of being in these quadrants, it would have been in these quadrants. Whoops. Would have been in these two quadrants. And then when x is negative 2, it does look like a slope of 2/9 would make sense. So it's a good idea to do a quick check, thinking about what the graph would look like and see if your answer is reasonable. All right, now let's look at how we would find the slope of a tangent at the transition point of a piecewise function. So in order to figure out what the slope is, I'd be looking at the derivative. But let's stop and think. In order for the slope to exist at a point, in order for a point to have a slope, or to have the slope of the tangent, it would need to be differentiable. So the first thing I need to figure out is this even differentiable at x equals 6? And in order to be differentiable, the first thing I need to check is it continuous? So let's check. If I plug in 6, so the limit as x approaches 6 from the left side of f of x would be 4 plus 6, which is 10. That's a 10. The limit as x approaches 6 from the right side, so coming from the greater of f of x, would be negative 3 minus 6, which would be negative 9. Since the limit as x approaches 6 from the left of f of x does not equal the limit as x approaches 6 from the right of f of x, this is not continuous. If it's not continuous, it's not differentiable. So we can't find the slope of the tangent. So this does not exist. There's a jump discontinuity here, so we couldn't draw the slope of the tangent to the curve at 6 because there's a jump discontinuity. All right, let's look at another example. Find the slope of the tangent for this piecewise function. All right, so the first equation says we use this rational as long as x is not 8. But then when x is 8, the function is equal to 16. Now this original function could be simplified because it has a removable discontinuity. When you can cancel out a factor, it's a removable discontinuity. So this would really just be the function y equals x plus 8. So up here at 8, except we would have a hole at x equals 8. Now the second part of this function says when x is equal to 8, I need to put a dot at 16. Now let's figure out where this hole would be. So if I took 8 and plugged it into this equation, 8 plus 8 is 16. So it turns out that this hole gets colored in by this part. So it is continuous. The limit from the left and the limit from the right are both equal to 16, and the function is equal to 16. So the limit as x approaches 8 from the left of f of x is equal to the limit as x approaches 8 from the right of f of x, which is equal to f of 8, which is equal to 16. This is what you would want to show on the AP exam, not that little line, not sure where that came from, to show that this is continuous, which is the first part to see if it's differentiable. So now that I know it's continuous, I need to see what the slope is. So I would take this equation, y equals x plus 8, or f of x equals x plus 8, and find the slope of that. So f prime of x would just be 1. The slope of this equation is 1 everywhere. So the answer to this equation would be 1. This question. All right. Find the equation of the line tangent to the curve at the given point. Anytime you see equation of the line in the problem, in your mind you should be thinking point slope form, which means you need two things. You need a point and you need a slope. The point is going to come from the original equation. The slope is going to come from the derivative of that equation. And then you're going to use point slope form. Y minus y1 equals m times x minus x1. Once you've put it into that form, put a box around it, because point slope form is an acceptable form for answers on the AP exam. Okay, so I need a point and I need a slope. Right now I have an x value, that's really my x1 value. So I already have one piece of my answer. I know that it's going to be x minus 5. So let's find the point. F of 5 would be negative 1 minus 5 squared. So f of 5 would be negative 1. Now notice that the 5 is going to be squared before we make it negative. So negative 25, f of 5 would be negative 26. All right, so that's really my y1 value. So y minus negative 26, which is going to become y plus 26. Now I just need the slope, and the slope is going to come from the derivative. So if f of x equals negative 1 minus x squared, f prime of x, constant goes away, use the power rule here, negative 2 comes in front, drop it down to 1, so negative 2x. The most common mistake is that kids will say negative 2 is the slope. That's not the slope of the original equation. At this point, negative 2 is the slope of the derivative, but that would be the second derivative, and that's not what we're asking for. So I need to know what f prime of 5 is. So f prime of 5, negative 2 times 5, is negative 10. So that's my slope for the entire equation. So I'd get y plus 26 equals negative 10 times x minus 5. You could put it into slope-intercept form, but you shouldn't. You should just stop in point-slope form. All right, let's do one more. This one's asking for the equation of the line normal. So normal just means that it's going to be perpendicular to the tangent. We're still going to need a point and a slope, and we're going to use point-slope form again. So let's find our point first. F of -5 would be 3 times -5 minus 2 times -5 squared. F of -5 would be -15 minus 2 times 25. F of -5, -15 minus 50. Sorry about that. F of -5 would be -65. All right. Now I need a slope, and to find the slope, we're always going to be using the derivative. So f prime of x, 3x turns into just 3. -2x squared turns into -4x. Again, -4 is not the slope of the original equation. That's the slope of the derivative. So I want to know the slope of the original equation when x equals -5. So f prime of -5, 3 minus 4 times -5, 3 plus 20 would be 23. So the slope of the original equation would be 23 at x equals -5. But I don't want the slope of the tangent or the slope of the original equation. I want to do the normal line. So the slope that I actually want to use is going to be perpendicular to 23, which would be -1 over 23. So now I want to do y minus y1 equals m times x minus x1. There was my y1 value. The x1 value was in the problem. And the slope was perpendicular to the tangent slope that I found using the derivative. So my answer for this problem would be y minus -65 equals -1 over 23 times x minus -5. You could leave it like this, or you can turn the double negatives into plus signs. When you see normal, everything's the same as the tangent line equation, except normal means you're perpendicular, so you use the opposite reciprocal. So change the sign and flip it. All right. Here's a practice if you want to try it, so hit pause and give it a shot. All right, here we go. So equation of the line normal, I need a point and a slope. Let's find the point first. F of 4 would be 4 over 4 plus 3, so 4 over 7. And then I need to use the derivative, so f prime of x. I would rewrite this original equation as 4 times x plus 3 to the -1 first. So the derivative would be -4 times x plus 3 to the -2nd. Or if I want to plug in +4, f prime of 4 would be -4 times 4 plus 3 to the -2nd, which can be simplified to be -4 over, this is going to be 7, and I'm going to move it down to the bottom, so 7 squared, which would be -4 over 49. Now, some of you guys are going to pick one of these answers because you see the -4 over 49, but remember, we want it to be normal. So we need to flip this and change the sign. So it's not going to be B or C. I know it's got to be one of these two equations, and now I just need to plug it in and work it out. So y minus y1 is 4/7 equals my slope. Again, I'm going to flip this and change the sign. So 49 over 4 times x minus 4. And then we need to simplify it. So 49/4 x. 49 over 4 times -4 would be -49. And then I'm going to add the 4/7 over to the other side. That's not going to be -45/7. It's going to be -339/7. All right. That's it for this video. Hope it helps.